These giants were made in Italy, and then they were sent by a special convoy, first along blocked-off roads, and then delivered by sea to a shipyard in the French town of Saint-Nazaire. Each of them consists of several thousand parts. Some of them are made right here in Trieste. Some come from subcontractors. Cast and forged blanks, for example, are sent from a metallurgical plant in the Czech Republic. The so-called connecting rods come here to the plant in this form, crudely forged, very coarse to the touch. Here, they are then installed in these machines. They each weigh 330 pounds, by the way. Many of us, when we were kids, not everyone of course, in shop class did something similar, carving out various objects. It's about the same here, only the size is much larger, and the accuracy is very high. As a result, the connecting rod is worked to, well, just to a mirror shine. After the lathe finishes, the connecting rod is then married to the piston and installed in the cylinder. In general, everything's familiar. Everything looks like a conventional internal combustion engine. But in this place, you feel like Gulliver in the Land of the Giants. The size of the parts is daunting. Everyone who has ever gone over the engine of their car, seen the pistons, immediately recognized them. Well, this one, believe me, is exactly the same. Well, a little bigger. This weighs about half a ton. And the volume of the cylinder in which it works is 6.5 liters. That, by the way, is a bit more than the total volume of my car's engine. Well, alright, not a bit more, several times more. And this, I repeat, is only one cylinder, and in two of the engines on Symphony of the Seas, there are 16 cylinders, just like this one. And the main difficulty here is that huge parts, that sometimes weigh several tons, must fit together perfectly. After all, there is so much force and heavy loads involved that the slightest deviation or inaccuracy can send the engine off the rails, and in the open sea, that can threaten a catastrophe. Therefore, manufacturing margin errors are as severe as with Swiss watches. Well, by the way, using the crankshaft as an example, you can easily understand the principle of operation of a piston engine. Look, in this position, for example, the piston would be in the upper position, and this crank pin is also up. At the same moment, the other piston is in the lower position, and the crank pin, respectively, is at the bottom. Thus, the pistons move up and down, and the shaft rotates. Everything is very simple, but the most amazing thing is that this particular shaft weighs 25 tons, its length is 26 feet, and it's made of one single solid piece of metal. Just unbelievable. By the way, there are only a few metal lathes in the world that can carve a 26-foot item like this from a multi-ton bar of high-strength alloy steel. The turner's worst nightmare here is to screw up even one detail. The crankshaft is worked on for several weeks, and it costs more than $1 million. Ultimately, after numerous checks and tests, the crankshaft and thousands of other parts are sent to the assembly area. In a few more weeks, the engine is finally ready, and now tests await it. If everything is in order, the engine is rolled back onto the ship, all technical fluids are drained, and it's checked again and again. In the testing chamber, the engine has already been checked out by numerous automated computer systems, sensors, and so on and so forth. But no one has done away with the good old visual control test. Everything here, again, is like in a car. We open the hood and look inside. Perhaps the most important difference between this engine and a car engine is that there are 12 of these hoods, or rather viewing windows. Behind each of these windows is one of the cylinders and valves connected by a connecting rod to the crankshaft. If you wait for the oil to drip down from the parts, you can simply see with your eyes if any jams or other metal defects have formed during the tests. When at this stage the inspectors give the go-ahead, the only thing left is to pack up the engine and send it to the customer. but that's easier said than done. Anyone who has ever, transported, say, a dresser knows that the most necessary thing to get that done are duct tape, some styrofoam. Oh, here we have some. Wow, and a lot of bubble wrap. When moving a finished engine, everything is about the same. All protruding parts are carefully wrapped with these foam corners, sealed with tape, cling wrap, and so on and so forth. Well, in general, everything is the same as when moving furniture. There is a slight difference, though. The weight of this dresser is 180 tons. It takes a week just to get it ready for transportation. By the way, at the same time, road services and a special platform, the only one in Europe that can support such a weight and size, are being prepared for the giant's move to the port. Only here, at the very end, in the finished goods warehouse, can you begin to understand the true scale of this giant engine. Its height is about that of a 3-story building. It weighs several hundred tons and generates the amount of electricity that would be needed for a small Moscow neighborhood. The actual biggest mechanical heart in the world of the world's biggest cruise ship. And let me remind you, Symphony of the Seas has 6 of them, and although at the same time, even at full speed, usually no more than 3 of them are working, the fuel consumption is still massive, and that's why the company that owns the ship uses a little trick. At the starting point of the journey, in Miami, they take on board only as much fuel as is needed to reach the next port, where fuel is cheaper, and when they're already in Uruguay or Mexico, for example, the liner is filled up with diesel all the way. Thanks to this, the ship owner manages to save several $1 million per season. However, there is one caveat. For some reason, the fuel from these countries often contains water. By accident, of course, I'm sure, but this is unacceptable for the engine. Therefore, all fuel is cleaned directly on the ship before being fed into the combustion chamber. But how can several tons of fuel be cleaned per hour and when moving at full speed too? And here, centrifugal force comes to our aid. Fuel enters these separators, which are in essence huge mixers, and it's spun at a breakneck speed. What happens in there? Water, which is heavier, is forced out to the walls, and the oil product, as the lighter portion, accumulates in the center and then enters the engine. 5th grade physics at work on the largest ship in the world. At the same time, the fuel in the separators is also heated. That makes it more runny and it therefore burns better. By the way, the liner has an electric drive. No, its powerful internal combustion engines do not directly rotate the ship's propellers. They spin generators that generate electricity. And then, along the high voltage lines hidden in the bowels of the liner, the current travels to the electric motors, which spin the propellers. This diesel-electric circuit makes the vessel more maneuverable. After all, an electric motor, unlike a piston one, can stop and change the direction of rotation almost instantaneously, and it doesn't need a gearbox. The motors, together with the propellers, can also rotate 360 degrees around their axis.